Hello viewers, this is Wagda Ronald and I want to thank you in advance for accepting to watch this video. So this video is the continuation of our solutions to UNEB Physics of the year 2019, and today we are going to look at questions 31 to 40. Maybe to remind you, in the previous video I left you with these questions and I believe you tried them out, so now we are going to work through them so that you can find out your mistakes and do the corrections where necessary. So remember that these are our constants. Acceleration due to gravity is 10 meters per second squared and specific capacity of water is 4,200 joules per kilogram per Kelvin. So where necessary, we shall be using these constants. And so also remember that this section is objective type and you are given 4 answers whereby you have to choose one which is most correct. So shall start with question 31. Says that figure 3 shows a bar magnet which has picked up an iron nail. If the plotting compasses P and R are placed in the positions shown, in which direction will R point? So this is P, a plotting compass, and this is R, a plotting compass. So this plotting compass is in this direction, meaning that now the fields of this will be in this form, such that, and if it's in that form, it means that this becomes the north and this becomes the south. So because this is the north and it is attracting this nail, it means that this part of the nail is south. And because this is south, this end of the nail will be north. Now because this is the north, the field will be in this form on this nail, whereby this is in this direction and this is in this direction. Therefore, if you look at this plotting compass, the direction of this plotting compass would be in this direction, which is the direction of the field. Therefore, when you look at these options, you shall realize that part D is the correct answer. Therefore, we shall say that the correct answer is D. So now we shall go to question 32. Question 32 says, when constructing large holes, some reverberation is left to occur because 1. It enables production of a loud clear sound. 2. The audience absorbs some sound and without reverberation left, sound is not heard clearly. C. The speakers in the hall need to hear the echo so as to hear what they are saying. Then D. All the sound will move outside the hall and the people inside will not hear. So this is not correct and this is also not correct. Similarly, this is also not correct. Therefore, this will be the correct option. Therefore, the correct answer will be B. Now we shall go to question 33. Question 33 says, which of the following is or are true about the magnitude of the force on a wire carrying current placed in a magnetic field? Roman 1. It is 0 if the wire is parallel to the magnetic field. Roman 2. It is small if the wire is not at right angles to the magnetic field. And Roman 3. It increases with strength of magnetic field. So all are correct, so shall look for the option. So this is not okay, this is not okay, this is not okay. So the only option will be part D. Next will be question 34. Question 34 says, a spanner of length 20 centimeters is used to tighten a nut. If a force of 15 newtons is applied at right angles, so know that word, right angles, to the end of the spanner, find the moment of the applied force. So this is our spanner, this is the nut, and we say that a force is applied at right angles to this spanner. So therefore this F will be now 50, and this length of the spanner will be the perpendicular distance. Therefore D will be equal to 20 centimeters, but change to meters to become 20 over 100. Now we have force and we have the perpendicular distance, therefore we can get the moment. Moment, remember, is equal to force times perpendicular distance. Therefore force is 50, perpendicular distance is 20 over 100, and when we rearrange you'll come up with 20 times 50 over 100. Now we're going to look for an expression which is exactly similar to this, and that would be our correct answer. So when you look at the four options, you realize that part B is the correct answer. So question 35 says, what happens to speed, frequency and wavelength of a wave as it travels from shallow end to the deep end of a ripple tank? So a ripple tank is of this shape, so it has water, and this is straight deeper is used to find out the various properties of water waves. So in this case we want to find out what happens to speed, frequency and wavelength as it travels from shallow end to a deeper end of a ripple tank. So that property is in this form. So this end is made shallower by adding a glass block inside the ripple tank. So this one is shallow and this part is deep. So when water waves travel from shallow water to deep water, the direction changes and both speed and wavelength increase, but frequency of the wave does not change. So frequency remains constant. Now let us use that to find out the solution to our question. So in this case, this frequency remains the same. That part will be cancelled out, part D will be cancelled out, because here they're saying that frequency changes. Then this part B says that speed decreases, but remember we said in our case speed has to increase, so this part is off. Now we're left with this and this. For both A and C, speed is increasing and frequency remains the same, which is also correct. But when you go to wavelength, for A they say that wavelength remains the same, and for C they are saying that wavelength increases. So this makes that part wrong, and that means that we end up with part C as our correct answer. So now we shall go to question 36. Question 36 says, an ideal, so know that word ideal, transformer has 2000 turns in the primary coil and 6000 turns in the secondary coil. This transformer is used to change an input of 24 volts and 3.0 ampere. What is the current output of the transformer? So this will be the schematic diagram of a transformer. This is the primary section and this is the secondary part. So in this case it means that our VP is the voltage is the input voltage, and this will be the output voltage. This is the number of turns of the primary coil and the number of turns of the secondary coil. So in this case NP will be equal to 2000, NS will be equal to 6000 turns. The voltage of the primary coil of the primary part was 24, which is the input voltage, and current at the primary part is 3 amperes. We know that the ratio of voltage of the secondary coil to voltage of the primary coil is equal to the ratio of the number of turns of the secondary coil to number of turns of the primary coil. That implies that when we substitute, we shall come up with this part, and when we make Vs the subject, we shall come up with Vs being equal to 72 volts. But remember, they told us that the transformer is ideal. Ideal means that power output is equal to power input. Therefore, expression for power is IV. So power output will be the power at this secondary part, which is IS, current of the secondary coil, and voltage at this part, output voltage, being equal to input current and and input voltage. Now when we substitute, we know that Vs is 72, which we have already calculated, IP is 3, which is here, and Vp is 24, which is here. So we are left with Is as the unknown, which is the current in the secondary coil. Therefore, when you make Is the subject, you should come up with 1 ampere. Now when you go back to our options, we shall realize that part A is the correct answer. So question 37 says, in an oil film experiment, the thickness of the oil film is taken to be the size of the oil molecules because Roman 1 part A, oil film is cylindrical, oil drop spreads until it is 1 molecule thick. Lycopodium powder makes the oil film visible. Not correct explanation. Volume of the oil is equal to volume of the oil film. So in this case, part B is the correct statement, so that our answer is B. So now we shall go to question 38. Question 38 says, Figure 4 shows a circuit diagram of 3 resistors of resistance 1 ohm, 6 ohm, and 6 ohm connected to a 2 volt supply of negligible internal resistance. Find the current through the 1 ohm resistor. So this is our circuit diagram. So before we do the calculation, I think let's first see the simulation of this circuit, how it operates. So this is a simulation of the circuit which is given in the question. So for example, if I want to see, if I close this, it means that current will flow, and if I want to see how current flows, I'll come and click here to show current. So I want current, so I'll first press that arrow. So when I close my switch, now current will flow. I think you can see the direction of current is from positive through the whole circuit to the negative. So when you increase this voltage, then the speed of this current will also increase, meaning the flow will also increase. So you can also show it in this form. So when I open, there's no current flows. When I close, that's when current flows. Now the first thing to realize is to find out, before you make the calculations, you have to find out which resistors are in series and which ones are in parallel. Now to know the resistors in series, you have to look at the current. I think you can see this current, it moves, but when it reaches here, it splits. One goes this side and another one goes this side. Now because current splits at this junction, it means that this resistor and this resistor will be in parallel. And when you combine the, so when you have to first get the resistance in parallel for these resistors, and when you get the combined resistance, it will now be one resistor. So what I'm going to do, I'll come and remove one resistor. So I managed to remove one. So this will be now the combined resistance of the resistors in parallel. And when you look at it, you realize that the current which flows through this resistor is the same current which flows through this combined resistance. What does that mean? It means that now this resistor and this combined resistance are in series. So we are going to use that knowledge to go through the solution to our question. So now for this case, when you look at this diagram, current, this is positive, so current will move in this direction like that through this resistor, and when it reaches here, it will split. One will go this side, another one will go this side. So what does that mean? It means that these two resistors are in parallel. So we are going to first combine these two resistors in parallel. I think you remember the formula for getting resistance in power, it says that product over sum. So resistance in power is equal to product over sum. So the product is 6 times 6 and the sum is 6 plus 6. 6 times 6 gives you 36 and 6 plus 6 gives you 12. So when you divide the two, you'll come up with 3 ohm. Now this 3 ohm is the combined resistance for those two resistors. So in the end, we have now this one combined resistor, and this combined resistor of 3 ohm will be in series with this one resistor. That means that getting the total resistance will be this one plus the 3 ohm, which is got from these two resistors in parallel. Now we're going to say that total resistance will be equal to 1 plus 3, which is equal to 4 ohm. But we know that V is equal to IR. Therefore, my V was 2, I is what I want, and R was 4. So now when I make I the subject, I'll come up with 0.5 ampere. So I'm going to compare this with the given answers. So when I compare, I realize that the correct answer is part A, which is 0.5 ampere. So now we shall go to question 39. Question 39 says refracting prisms are preferred to plane mirrors in optical instruments because Roman 1, no energy is lost to refraction and reflection, which is okay. Clear images are formed, which is okay, and they are easier to fix. Therefore, when you look at all these options, you realize this is not okay because it has eliminated Roman 3. This is not okay, it has eliminated Roman 1, and it's not okay, it has eliminated Roman 2. So this will be the correct answer. So correct answer was part D. Now we shall go to question 40. Question 40 says, Figure 5 shows a structure of beams built to support a load. Which of the beams below are under tension? Now, how do you know beams that are under tension and those under compression? So the ones under compression, if you remove that beam, it means that the system collapses inwards. But the ones in tension, when you remove that beam, the system will collapse outwards. Now we are interested in beams under tension. Now let's start with part A. Part A says the pair of beams under tension is OR and PR. So when you look at OR, when I remove this beam, the system will collapse inwards. So this part O, joint O, will go inwards. Therefore, OR is in compression. That means that this is not okay. When we go to S2 is this. So when I remove this beam, this system will fall apart outwards. For example, this part will go this side and this will go this side, meaning that this one is in tension, which is okay. Then when you go to UV, when I remove this, the system will collapse outwards. For example, this one will slide this side and this one will slide this side, meaning that this one is in tension. Therefore, that is correct. Because it is only one answer which is correct, means that automatically these will also be wrong. Therefore, the correct answer will be B. So we have gone through the solution to this problem, to the questions which were previously left in the previous video. Now I'm going to leave you with 5 more questions, and these are now structured. We have been dealing with objective questions. Now we are going to structured questions, but please don't forget to subscribe. If you have not said subscribed, you can click on that subscribe button below so that you get updates on the videos that will be uploaded soon. So that brings us the end of this video. Thank you for watching this video, and please subscribe to my channel Roa e-learning platform so that you can get updates of any video that will be uploaded, and please share this video to as many students as possible so that we all excel as a family.